Our next example in the guided practice is a profit, revenue, and cost example, or a business example. And we talked about the relationships between revenue, cost, and profit in the lecture, but let's go over them now. X is going to be the number of items that we're going to produce and then sell. So cups of lemonade at our lemonade stand or something like that. And rho, or little p, not to be confused with capital P, is the price per item. So you'll notice that in the lecture I was drawing something that looked like a lowercase p, but it's really a Greek letter rho. And I think that this particular PDF was used using lowercase p just because of ease of character, but you should really be using rho there. And this is for price per unit. So as a function, rho of x is the price per unit, or the price each, as opposed to the price for everything altogether. Now, when you are talking about revenue, revenue is your gross. So that's how much money you're taking in at your lemonade stand, not your profit, but just how much money you're generating at the lemonade stand. And that's an easy calculation. Revenue is the number of items you sold times the price per item, right? Or in this case, X times rho, or sometimes written X times rho of X, where rho of X is the price. Now, the profit is revenue minus cost. That's how much money that you took in gross. This is sometimes referred to as the net in a business situation. And that is the total money made revenue when you subtract out your cost for starting up your business. So if you're starting a lemonade stand, revenue is how much money you take in at the stand. You have to subtract out the cost of cups, setting up your stand, sugar, lemons, that whole deal. And whatever is left over, that's how much you profit or net from your venture. So what we're going to look at is another question that, while it's related to business, it's also got a quadratic equation underlying the relationship, or a quadratic function. And typically in these problems, the profit and the revenue will be quadratic functions. So let's take a look. The relationship between the number of pencil sharpeners X a company can sell each week and the price of each sharpener rho is given by the equation X is equal to 1800 minus 100 rho. At what price should the sharpeners be sold for the weekly revenue to be $7,200? So this question is, at what price? What should rho be so that the revenue is equal to 7,200? Well, let's set that up. We know from our relationship above that the revenue is the quantity times the price. And they've given us some information here. They tell us that the revenue is 7,200. And they told us what X was in terms of rho. So in this particular case, we can replace X with this relationship. And what we get is 1,800 minus 100 rho times another factor of rho. And if we multiply that out, we get 7,200 is equal to 1,800 rho minus 100 rho squared. And this is quadratic. If we put it in standard form, we bring everybody over to one side here, we're going to get 100 rho squared minus 1,800 rho plus 7,200 is equal to 0. We can scale that down a little bit by dividing everybody by 100. To solve this relationship, we get rho squared minus 18 rho plus 72 equals 0. Excuse me, now it looks like I'm running out of room here, so let me move this over just a little bit. Okay, so let's start working in the other direction here. So can we factor this at all? Let's see here. Rho and rho. Now, if you can't factor this, that's okay. You should be able to use quadratic formula. But I need two numbers that multiply together to give me 72, but add together to give me negative 18. And I think negative 6 and negative 12 will do that. So it looks like rho is either $6 or $12. And it looks like we have two answers. So we have two options. If we want to make $7,200 each week selling these pencil sharpeners, we either need to set the price at $6 or at $12. Find, in the next question here, it says, find the price rho that will bring the maximum revenue. And what is that maximum revenue? Well, again, you have to remember here that the revenue, R as a function of X, is this function 1800 rho minus 100 rho squared. And since that's quadratic, if we were to graph that, it would be a parabola. Since the leading coefficient, the A value, is negative. In fact, let me rewrite that as negative 100 rho squared plus 1800 rho plus 0, so that it goes through the origin or has a y-intercept of 0. And because the leading coefficient is negative, that parabola opens downward. Now, what we want to figure out is if this is, this is the revenue as a function of rho, not of X. And so if we place rho here, this is revenue. And the question is, what is the price that will generate the max revenue? So this is a vertex question, and we're looking for the vertex at h comma k, and we know the formula for that. H is negative b over 2a, which in this case is negative 1800 divided by 2 times negative 100, which is 9. So we need to sell 9 pencil sharpeners per week, apparently. And if we can do that, sorry, that's the price, excuse me, $9 per pencil sharpener. That will generate the maximum revenue, and the revenue generated at $9 is going to be negative 100 times 9 squared plus 1800 times 9, which is going to be negative 8100 plus, let's see, 90, 72. Oh, come on. 162.00. And that will be $8,100. So, if we price the pencil sharpeners at $9 each, we'll get the maximum revenue of $8,100 per week. And that is that ordered pair. 9, 8,100. And then it says graph the revenue function. R of rho. We're going to have to make this the rho axis, and we're going to have to make this the R axis. But this particular PDF has a graph from negative 10 to 10 and negative 10 to 10 in the rho and R direction, which is not going to be sufficient. So what do we already know? We know that the vertex is at 9, 8,100. So we're going to have to change the scale here quite a bit. Let's see here. Let's do this in 3s instead of 2s. We'll make this 3, 6, 9, 12, 15, negative 3, negative 6, negative 9, negative 12, negative 15. And as far as the vertical scale goes, gee whiz, let's make this, 8,100, geez. Let's make this 2,000, 4,000, 6,000, 8,000, 10,000. And we know that the vertex is 9, 8,100. 9, 8,100. So just to estimate that, let's blow this up a little bit. Maybe right about there. 9, 8100. Now that's our vertex, so that we know that our axis of symmetry is going to go right through the middle there of our vertex. So let's just put that in. There's our axis of symmetry. Move that over a little bit. Just a smidge. There we go. Perfect. Okay. Now, what else do we know? Well, if we look at this function, our revenue function as a function of rho was negative 100 rho squared plus 1800 rho. And so that has an A value of negative 100, a B value of 1800, and a C value of 0. So because the A value is negative, this parabola opens downward, as we saw before. In fact, I actually already drew everything up here. I don't know why I'm doing this again, but only because the question asked us. The C value is 0, so this goes through the origin. And so it's going to hit 0 again due to symmetry here. It's going to come up through that 0. It's going to max out. And then it's going to have to come back down on the other side. And since the distance from 0 over to 9 is 9, we're going to go another 9 units over to the next 0. So this next one is actually going to occur out here at 18 somewhere. And it looks something like that. There is our revenue function. This is the revenue as a function of the price. And there you have it.